All right. Hi, guys. So we are starting chapter 4. It's going to be a small chapter that's going to just fit in these 3 weeks before Christmas break. There will be an exam right before break, but it's going to be very quick, very brief. It shouldn't take you more than like 30 minutes, so kind of think of it as a quiz, actually. And this whole unit is going to be on this thing called nomenclature, which is a very fancy way of saying to name. In the last unit and the units before, we've been taking elements and putting them together into compounds. And now you are going to learn how to turn those compounds into their proper name, okay? We're no longer going to be referring to things as like NH3. We're going to be able to call it ammonium or sodium chloride, okay? Naming is really important. It's important to know what you're talking about and communicate what you're talking about properly. And therefore, we're going to spend just a short 2.5, 3 weeks learning how to name everything. Okay, cool. All right. So today you're going to turn ionic compounds into their proper names. Let's begin. So the do now asked you to look at the periodic table and circle the elements that take 2 or more charges. Okay. So that takes 2 charges, 2 charges, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2. And down here we have a few more that take on 2 charges. Okay, awesome. And then it asks, what type of elements are they? They should say are, excuse me. So the majority of them are actually transition metals, which is the answer I was looking for. They are transition metals because they sit in this box that we have rarely discussed yet in chemistry. We're going to start venturing into this uncharted area, all right? So these are the transition metals. Most of them are transition metals. That includes this group here as well. This group are also transition metals. And then we have just a few that sit outside in the metal zone. Okay, but mostly these are transition metals. Okay? All right. Let's move on. So quickly, I wanted to review a few things with you. Since we are naming ionic compounds, I wanted to review what ionic compounds are. You should know from your test that you had just a few days, but just in case our brains are feeling a little slow, I'll let you know that ionic compounds are metals bonded to nonmetals Okay, so for an example, we have sodium Na bonded to chlorine. Sodium is the metal, and chlorine is the nonmetal. All right, let's continue on. The metal takes the positive charge, and the nonmetal takes the negative charge. Whoop, don't know what happened to my pen there. That was weird. Let me erase that. Okay, let's give this a try. There we go. So the metal takes the positive charge, and the nonmetal takes the negative charge. So if we had sodium chlorine, this is the metal, and it takes that positive charge, and this is the nonmetal, chlorine, and it takes the negative charge. The metal takes a positive charge because it gives up the electrons, and the nonmetal takes a negative charge because it takes the electrons. And lastly, this is a complete transfer of electrons. So again, the metal takes a positive charge, the nonmetal takes a negative charge. The metal takes that positive charge because it gives up its electrons. The nonmetal takes a negative charge because it takes that electron. And so this is actually a complete transfer of electrons. So let's get into naming. All right, so we're going to start with naming group 1 and 2 metals bonded to a nonmetal. So group 1 and 2. So anytime you see a metal that falls into this zone, you're going to follow these steps, and we're bonding them with our nonmetals, which is in the green. Okay, so anytime you see this group 1 and 2, which is in the red, bonded to a nonmetal, which is in the green, you're going to follow these steps. Okay. So first things we want to do is we're going to put together this compound, lithium and oxygen. So again, lithium takes a +1 charge, and oxygen takes a -2 charge. And when we put ionic compounds together, you know that you crisscross your charges. So you should have Li2, oxygen 1. So let's name Li2, oxygen 1. Let's give it a name. So the first thing you want to do, again, we're trying to name Li2, oxygen 1. The first thing you want to do is you want to name the first listed element. So lithium, Li is lithium. The second step is that you want to list the second element, but you want to change the ending with "ide." So we have Li2O. We know that our first element is lithium, but the second element is oxygen. So we're going to find oxygen over here, and we're going to actually use the "ide" ending. Do you see here how it's oxygen turned into oxide? So this is going to become oxide. So our element, oxygen, goes from oxygen to oxide, and our compound is lithium oxide. There you have it. Okay. That's how you name group 1 and group 2 metals with a nonmetal. You name the first element, which is typically the metal listed, and then you name the second element with its "ide" ending. So fluorine becomes fluoride, chlorine becomes chloride, bromine becomes bromide, iodine becomes iodide, nitrogen becomes nitride, and oxygen becomes oxide. Okay, nice. Now let's practice. I'm going to do the first two. I'm going to do the first one, and you're going to go do the next two. So we have NaCl. Our first step is to name the first listed element, which we can find in the periodic table, and it's named sodium. The second step is to name the next listed element with its "ide" ending. So this is chlorine, so it's going to become chloride. Okay, I want you to go do 2 and 3 on your own. When you're done those, you can move on to the next slide. Okay. We are now going to name transition metals bonded to nonmetals. So our transition metals are the metals that are in this boxed area in the red, and then our nonmetals again follow that staircase. in the green. So anytime that a metal falls into this red zone, you're going to use these steps instead. Okay? All right. So the first thing I want to do is put together FeS. So Fe is iron. If you were to look on the periodic table, it can take a +2 or a +3 charge. At this moment, it's going to take a +3 charge. S takes a -2 charge. We crisscross our charges, so it becomes iron with that little 2 and sulfur with that little 3. So we are going to name Fe2S3. All right. So the first thing we want to do is we have Fe2S3, and what we want to do for our first step is to reverse the crisscross. So the 3 is going to go back up to the top of the F and become a +3. And that 2 is going to go back up to the S and become a -2. So you know that iron takes that +3 charge, and the sulfur takes that -2 charge. Okay? The charges are really important. The next step says that you want to name I'm going to put the charges up top so you can see what charge they take. All right. The first step says that you want to name the first element listed, but add Roman numeral for the charge. So the first element is iron, and then it takes a +3 charge. So we're going to come over to the 3, and we're going to look at the Roman numeral, and we need, which is 3 lines for that 3 charge. Okay, so it's iron 3. Let's look at the next step. So we The second step says that you want to name the third step, says that you want to name the second element listed, but replace the ending with "ide." So we have S, which is sulfur. So our sulfur is going to change into sulfide. There's that "ide" ending. So this is iron 3 sulfide. Okay? So you reverse the crisscross to get the charges. So that 3 at the bottom of the S jumps up to the top of the Fe, because you know to make the element you have to crisscross those charges down. So now we are reverse crisscrossing up to determine the charges. You found that iron takes a +3 charge. So since it's a transition metal and it can take multiple charges, you have to determine the charge it's taking and put it in the name. Because transition metals can take multiple charges, it is important to put the charge it takes in its name. That way you know which charge iron is taking when you try to use this compound. Okay? All right, let's move on. So let's practice. So we have copper, chloride. All right, so we're going to reverse crisscross those charges. So we know that there's a little 1 here. That 2 is going to crisscross back up to the copper, so plus 2. And that 1 goes up to the chlorine. So now I need to name the first element, which is copper. And then we have to write in its charge for the Roman numeral. So 2 takes the 2 lines. You can reference your sheet. And then the chlorine becomes chloride with that I ending. Okay. I'd like you to go practice with 2 and 3. When you're done, you may move on to the next slide. Okay, so now we're going to name group 1 and 2 metals bonded to many nonmetals, which are called polyatomic ions. So again, group 1 and 2 is here, highlighted in the red. And then my many nonmetals, which are polyatomic ions, are actually in this table. So if you look closely, it's many nonmetals bonded together, and they've been given very specific names. So for an instance, if we look here, we have a carbon, 3 hydrogens, another carbon, and 2 oxygens, and that's been given a very specific name of acetate. Okay, and so we're going to reference this green box for these steps. And so anything in this green box is going to be bonded with anything in this red area. Okay? So again, polyatomic ions, they are many nonmetals bonded together. Okay. Poly, like the actual word poly means many. And atomic means atoms. Oh, not sure what happened to my pen there. There we go. Okay, so it's many atoms together, or many nonmetals bonded together. Again, if you just look at this table here, over here you have chlorine bonded to 4 oxygens. We call that perchlorate. Where these names came from, scientists invented them and they've stuck. It's much easier to give a group of things one name than try to name every single element in that molecule. It can get very long and very crazy. So very specific elements like these that have been grouped together have been given their own specific name. Okay? Kind of like a nickname. So we are going to bond together CaPO4. So we have calcium takes a +2 charge. If you look at our chart, PO4 takes a -3 charge. So now we're going to crisscross the charges. So that 3 will come to the bottom of the Ca. And that 2 is going to come to the outside of that PO4. So when I have a polyatomic ion, I typically put it in parentheses. PO4, and then that 2 that we just crisscrossed down comes to the outside of the parentheses. So it looks like Ca3PO4 with the 2. So again, we're going to name Ca3PO4 2. Perfect. Okay. So let's see. Our first step, we have Ca3PO4 in that parentheses with the 2. The first step says to name the first element listed. Well, Ca is calcium. The second step says to name the polyatomic ion using the chart. So far we have now let's go find PO4. Here it is. It's called phosphate. phosphate. Okay. Calcium phosphate. That's your answer. Okay, so I'm going to do the first one, and then I want you to practice this next two. So we have CaNO3. We named the first one, which is calcium again. And the second element is nitrate, if I remember correctly. Calcium nitrate. Okay. All right, I want you to try the next two. Make sure you reference your polyatomic chart. Okay? All right. When you're done those two, we're going to move on to the next slide. Our last naming. This time we're going to use transition metals. With our polyatomic ions. Okay. Let's give it a try. So the first thing we'd like to do is put together, oh, my pen. I'm so sorry, guys. Cu takes a +2 charge. PO4 takes a -3 charge. We're going to crisscross these charges, so the -3 comes down to the Cu. And that +2 goes to the bottom of the PO4. Okay, so we're going to name Cu3 PO4 2. Okay, let's give that a name. Again, we have Cu3 PO4 2. The first step, again, with transition metals is to reverse the crisscross to determine charges. So the 2 is going to come up top to the Cu, so we know that Cu takes a +2 charge, and that 3 is going to crisscross reverse back up to the PO4, so know that the PO4 takes a -3 charge. Okay. All right, now you want to name the first element listed. So Cu is copper. Okay, second step done. Oh, shoot. I can't go back. Darn it. Okay, so hold up, guys. It was supposed to be copper. Here. Cu PO4 with the 2. We know that that's Cu. The copper took a +2 charge and the Cu took a -3 charge. We named it copper. And then because it's a transition metal, this is where I just made my error on the last slide, so please make sure you fix this. That +2 needs to be put into a Roman numeral of 2 lines. And now the third step says you need to name the polyatomic ion using the chart. So PO4 is here. And again, it's phosphate, so we just write phosphate. So our compound is copper 2 phosphate, and you must include charges in the name. You must include charges in the name for transition metals because it can take 2 charges, so you need to know which charge it's actually taking. So you need to know which charge it's actually taking. Okay? You need to know which charge it's actually taking, which is why you reverse crisscross and put the charge in the name. All right. Let's practice. So we have AlNO3. We named the first element listed, which is aluminum, aluminium. We reverse crisscross. So in a case like this, when there's no parentheses, you can put them in and you know that there's a 1 here and that there's a 1 there. So we reverse crisscross, so aluminum taking a +1 charge. And the nitrate taking a -1 charge. So it's going to be aluminum 1 and then nitrate. Okay. I would like you to go do the next 2 on your own, and when you are done, you may begin the practice, okay? All right.